For over 65 years, humans have been diving to the deepest point on Earth. Each time, explorers descend nearly 7 miles through total darkness, enduring pressures that would crush steel to reach a place more remote than the surface of the Moon. Dozens of dives have been made since the first attempt in 1960, each one revealing more about a world we barely understand. So here's the question: what's actually down there? What did they find in the crushing darkness at the bottom of the Mariana Trench? And why is the answer both more wonderful and more disturbing than anyone could have imagined? Let's find out. The Mariana Trench is located in the western Pacific Ocean, roughly 200 miles southwest of the U.S. territory of Guam. It's a crescent-shaped scar in the ocean floor, stretching for about 1,580 miles from north to south, making it one of the longest geological features on Earth. But it's not the length that makes the Mariana Trench remarkable. It's the depth. The trench plunges to a maximum depth of 36,037 feet at a point called the Challenger Deep, named after the HMS Challenger expedition that first measured it in 1875. That's 10,984 meters, or nearly 11 kilometers down. To put that in perspective, if you placed Mount Everest at the bottom of the trench, its summit would still be over 2 kilometers beneath the surface of the ocean. The Mariana Trench isn't just deep. It's the deepest point in all of Earth's oceans, the lowest elevation of the Earth's crust, the most extreme environment on the planet. And for over a century, it remained almost completely unexplored. A mystery darker and more alien than the surface of Mars. The Mariana Trench exists because of a collision that's been happening for millions of years. On one side is the Pacific Plate, one of the largest tectonic plates on the planet, moving steadily westward. On the other is the smaller Mariana Plate, carrying the Mariana Islands and the surrounding seafloor. When these two plates meet, the Pacific Plate doesn't stop. It dives beneath the Mariana Plate in a process called subduction. The Pacific Plate is oceanic crust, older and denser than the Mariana Plate. So, physics demands that it goes down. Right at the point where the plate begins its descent into the mantle, the seafloor tears open, creating the trench. What makes the Mariana Trench so extraordinarily deep is the age of the crust being subducted. The Pacific Plate here is some of the oldest oceanic crust on Earth, 170 million years old, dating back to the age of dinosaurs. Old oceanic crust is cold and dense, which means it sinks deeper than younger crust. That's why this trench is the deepest point on the planet. It's a window into geological time, where rocks older than the Atlantic Ocean are being pulled back into the Earth. If you could somehow survive the journey to the bottom of the Mariana Trench, here's what you'd experience. At a depth of 36,000 feet, the water pressure is over 1,000 times greater than at the surface. That's roughly 8 tons pressing down on every square inch of your body. The equivalent of having 3 cars stacked on your thumbnail. At that pressure, the air in your lungs would compress to nothing. Your bones would splinter. Any unprotected human would be crushed instantly. The temperature hovers just a few degrees above freezing, between 34 and 39 degrees Fahrenheit, roughly 1 to 4 degrees Celsius, and it's dark. Not just dark, but utterly, completely black. Sunlight can't penetrate beyond about 1,000 feet. By the time you reach 3,000 feet, you're in what's called the midnight zone. The Challenger Deep is more than 10 times deeper than that. It's a place where no ray of sunlight has ever reached, where the concept of day and night has no meaning. For most of human history, scientists believed nothing could survive in such an environment. The pressure alone should make life impossible. The cold, the darkness, the complete absence of photosynthesis, all of it pointed to a lifeless abyss. The question wasn't whether life existed at the bottom of the Mariana Trench. The question was whether humans could even get there to confirm it was empty. Subscribe for more explorations of the ocean's extreme zones. In 1960, two explorers climbed into a steel sphere barely 7 feet in diameter, sealed the hatch, and began the longest descent in human history. They piloted a strange-looking craft that was part underwater blimp, part pressure capsule. A massive tank filled with gasoline for buoyancy sat above a tiny steel sphere designed to protect the crew from crushing pressure. It was cramped, cold, and primitive with no cameras and no sampling equipment. The mission had one goal: prove that humans could reach the deepest point on Earth and survive. The descent took 4 hours and 47 minutes. At around 30,000 feet, they heard a loud crack that shook the entire vessel. One of the outer plexiglass windows had fractured under the immense pressure. The explorers faced a decision: abort and surface, or continue into the unknown. They continued. At 10:06 p.m., the craft touched down on the ocean floor at a depth of 35,800 feet. The temperature inside the cabin had dropped to 7 degrees Celsius, just above 44 degrees Fahrenheit. They were freezing, exhausted, and sitting in near total darkness at the bottom of the world. They had 20 minutes before they needed to begin the ascent. And then they saw something through the viewport. Moving slowly across the seafloor was what they described as a flatfish about 1 foot long and 6 inches across. Then shrimp-like creatures. The bottom wasn't empty. There was life down here. The craft had no way to take photographs, no way to collect samples. When they surfaced hours later and reported what they'd seen, some scientists were skeptical. A flatfish at that depth, it seemed impossible. But one thing was certain: they had proven humans could reach the bottom. The question now was whether anyone would ever go back. They didn't go back. Not in 2 years, not in 10, not for over half a century. The first descent had accomplished something extraordinary. But as a scientific instrument, it was limited. It couldn't take photographs. It couldn't collect samples. It could barely maneuver on the bottom. The 20 minutes spent at the Challenger Deep produced no tangible data, no specimens, no images, just 2 eyewitness accounts of what they'd seen in the darkness. By the end of the 1960s, manned exploration of the deepest ocean trenches was abandoned. The craft was too expensive to operate, too difficult to maintain, and offered too little scientific return. The focus shifted to unmanned vehicles, remotely operated submersibles and landers that could be dropped to the seafloor and retrieved days later. Technology improved. Remotely operated vehicles became more sophisticated. Scientists sent cameras and sampling equipment to Hadal depths and brought back glimpses of life in the trenches. But no human returned to the Challenger Deep. The first and only eyewitness account of the deepest point on Earth remained frozen in time, a brief moment in 1960 that no one had been able to repeat or verify until 2012. In 2012, 52 years after that first descent, a solo explorer squeezed into a vertical torpedo-shaped submersible and began the journey to the Challenger Deep. This time, the mission was different. The goal wasn't just to reach the bottom. It was to bring cameras, sampling equipment, and the technology to actually study what was down there. The descent took 2 hours and 36 minutes. The explorer sat alone in a pilot sphere so cramped he couldn't extend his arms, watching through a 9.5-inch thick window as the darkness closed in around him. When he reached the bottom at 35,756 feet, he became the first person to make a solo dive to the deepest point on Earth, and the third human ever to see it. What he found surprised him. The seafloor wasn't teeming with bizarre creatures. It was, in his words, lunar and desolate. A flat, barren plain of fine sediment stretched out in every direction. He saw small shrimp-like amphipods, translucent and ghostly, drifting near the bottom. But there were no fish, no obvious signs of the abundant life some scientists had hoped to find. He described the feeling as one of complete isolation from all of humanity, but the real discoveries came from what he brought back. Sediment samples revealed 68 new species, most of them bacteria. The submersible's cameras captured footage of microbial mats clinging to chemically altered rocks on the seafloor. Evidence of chemosynthesis, life fueled not by sunlight, but by chemical reactions in the Earth's crust. During test dives in a neighboring trench, the team found giant amphipods 7 inches long, the largest ever recorded at that depth. The explorer had planned to spend 6 hours exploring the bottom, but a hydraulic fluid leak disabled the mechanical sampling arm and limited mobility. After just 3 hours, he was forced to return to the surface. He'd proven that modern technology could reach the Challenger Deep and bring back real scientific data. But 3 hours wasn't enough. The trench had revealed glimpses of life, but it was clear that unlocking its secrets would require more time, more dives, and better equipment. 7 years later, in May of 2019, a new submersible reached the bottom of the Challenger Deep at a record depth of 35,853 feet, 10,927 meters, the deepest dive ever recorded. But the mission didn't stop at one dive. It returned again and again. These became the first repeated crewed visits to the Challenger Deep, spending hours methodically exploring the seafloor, collecting samples and documenting what previous explorers had only glimpsed. The expeditions discovered 4 new species of amphipods, prawn-like crustaceans adapted to survive the crushing pressure. They found vibrantly colored rocky outcrops that appeared to be chemical deposits, evidence of active geology at the bottom of the trench. They filmed sea cucumbers slowly crawling across the sediment and captured footage of ecosystems no human had ever seen before. Since 2019, these advanced submersibles have made over 20 successful crewed dives to the Challenger Deep, transforming it from the most inaccessible place on Earth into the most systematically explored deep ocean environment. But they also found something that no one wanted to see. Lying on the seafloor at the deepest point in the ocean, nearly 7 miles beneath the surface, in a place more remote than the summit of Everest, more isolated than the surface of the moon, the explorers spotted a plastic bag and candy wrappers. The discovery was described as deeply disappointing, a stark reminder that human contamination had reached even the most remote point on the planet. Specimens of the creatures they found were collected and sent to laboratories for analysis. Scientists opened them up and examined their tissues. Nearly every animal tested contained microplastics in their bodies. Plastic that had been thrown away on the surface had found its way to the bottom of the Mariana Trench, and the creatures living there were consuming it. The discovery shocked the world. If pollution could reach the Challenger Deep, it could reach anywhere. There was no corner of the ocean, no matter how deep or remote, that remained untouched by human activity. What shocked you more? The incredible life they found, or the plastic that shouldn't be there? Let me know in the comments. So, what actually lives at the bottom of the Mariana Trench? Across all the expeditions from 1960 to the present day, explorers have found life far more diverse and resilient than anyone expected. The deepest fish ever recorded is the Mariana snailfish. Discovered in 2017 at a depth of 26,830 feet, just over 8,000 meters down, these translucent, ghostly creatures have gelatinous bodies with no swim bladder and skeletons made of soft cartilage rather than bone, adaptations that allow them to withstand pressure that would pulverize most other fish. They represent the absolute depth limit for vertebrate life on Earth. But fish are just the beginning. The trench is home to supergiant amphipods, shrimp-like crustaceans that grow up to 7 inches long. Scientists discovered that these creatures use aluminum to strengthen their exoskeletons, making them the first known species on Earth to incorporate this metal into their bodies. They extract the aluminum from sediments on the seafloor, a biochemical trick found nowhere else in nature. The Dumbo octopus, named for its ear-like fins, is the deepest living octopus known to science. Unlike shallow water octopuses, it has no ink sac because it encounters so few predators at depth. Giant single-celled organisms called xenophyophores, some measuring several inches across, cluster on the seafloor like alien flowers. Sea cucumbers crawl through the sediment, processing organic matter that drifts down from the surface world miles above. And then there are the microbes, bacteria and archaea that thrive in conditions humans can barely comprehend. Organisms that have evolved biochemistry fundamentally different from anything found in sunlit waters. Life at the bottom of the Mariana Trench isn't just surviving. Against all odds, it's thriving. But the most groundbreaking discoveries were yet to come. Between August and November of 2021, advanced crewed submersibles conducted dozens of dives into the Mariana Trench as part of a major international research initiative. Analysis of the samples, published in 2025, rewrote our understanding of life in the deepest ocean. The expeditions collected over 1,600 sediment samples from depths ranging from roughly 20,000 to 36,000 feet. Sequencing revealed more than 7,564 new microbial species, 89.4% of them completely unknown to science. These weren't just rare bacteria. They were thriving populations with remarkably diverse survival strategies, adapted to one of the harshest environments on Earth. Comparative genomics showed two dominant evolutionary paths. Some microbes had evolved ultra-streamlined genomes, tiny and hyper-efficient, focused on a handful of critical functions to conserve energy in a nutrient-starved world. Others developed larger, versatile genomes packed with flexible metabolic pathways, allowing them to switch between scarce food sources, including the ability to consume carbon monoxide and other trace chemicals seeping from the crust. Selection pressure, not random drift, shaped these extremes. But the most astonishing discovery came at a depth of 31,270 feet, 9,533 meters down. The team found massive colonies of tube worms and bivalves, thousands of organisms clustered together in dense aggregations. These were chemosynthetic communities, ecosystems that don't rely on sunlight at all, but instead draw energy from methane and other chemicals seeping through cracks in the seafloor. Video captured tube worms up to 12 inches long, swaying in the current like an underwater forest. Fields of clams packed so densely they covered the sediment like cobblestones. The scientists described it as a river of life flowing along the trench floor, the deepest and most extensive chemosynthesis-based ecosystem ever discovered on Earth. The organisms clustered around microbial mats that looked like snow on the seafloor. Those mats were producing methane through biological processes in one of the most extreme environments imaginable. The implications were staggering. If chemosynthetic life could thrive at the bottom of the Mariana Trench, similar ecosystems might exist in other trenches around the world, places we've barely begun to explore. Recent global studies have only deepened the mystery, confirming microplastics now permeate every layer of the ocean, with concentrations in the Hadal zone reaching thousands of particles per liter. Plastic integrated into the very tissues of these ancient ecosystems. So, here's the answer to the question we started with. What did they find at the bottom of the Mariana Trench? They found life. Not the barren wasteland that scientists expected, but thriving ecosystems more diverse than anyone imagined. Creatures that survive in total darkness under crushing pressure. Organisms with biochemistry fundamentally different from anything in the sunlit world. Evidence that life on Earth might have originated not in shallow pools, but in deep ocean trenches, fueled by chemistry rather than light. And they found us. Plastic bags, candy wrappers, microplastics embedded in the tissues of creatures living down in a place so remote that more people have walked on the moon than have visited it. The Mariana Trench revealed something profound. The deepest point on Earth is not lifeless. It's not pristine. It's a thriving alien world contaminated by human activity, holding both clues to the origin of life and evidence of our impact on every corner of the planet. The Mariana Trench has taught us that the most extreme places on Earth are not beyond life's reach, and neither are they beyond ours. Which discovery matters more? The alien ecosystems thriving in crushing darkness, or the plastic waste we left behind? Let me know in the comments, and don't forget to subscribe for more deep ocean explorations. Share this with anyone who needs to see what lies at the edge of the possible. Because understanding the abyss might just be the key to protecting the only home we have.